Right, in this first one, we're trying to prove that the triangles are similar and solve for x. And we notice it's kind of like a smaller triangle inside of a bigger triangle. So I think of these as like small versus big as we're working with them. So we're going to say that there is a shared angle. We call this angle E. We can say that angle E is congruent to itself by the reflexive property. And then we don't have any parallel lines to be able to say corresponding angles or anything like that. So my one angle is probably the only angle I can get from this picture. I'm going to have to use side ratios in order to do a side angle side similarity. So notice that this whole side is 4 plus 12 or 16, and that this whole side is 6 plus 18 or 24. So when we're doing the small is to big ratio, we need to use those big side numbers. So we're going to go small is to big. So that's going to be side RE is to side IE, or 12 is to 16. And now I'm going to the right-hand side, we're going to say small is to big. So FE is to NE, and that's 18 over 24. Well, to see if these side ratios are equal, we need to reduce them. So let's say 4 goes into 12 3 times, 4 goes into 16 4 times, 6 goes into 18 3 times, 6 goes into 24. Notice that we get the same ratio, so we can say ratios of corresponding sides are equal. Therefore, we have our two sides with proportional 3/4, 3/4, and we have our one angle. So we can say triangle REF is similar to triangle IEN by side angle side similarity theorem. Once we prove the triangle is similar, we can then go do the calculating and solving for x. So I'm trying to solve for this x right here, which is on the small triangle. So I'm going to go small is to big and then I can use either the left or the right. Small is to big. So if I want to use 12 and 16, I can, or if I want to use 18 and 24, I can. Your choice. So I get 16x equals 120. Divide that on a calculator for me. Did you get 7.5? Okay. Next one has the parallel line marks. That means we do have the corresponding angle possibility here. So you can do this one of two ways. You can say that this angle, oops, wrong side. You can say that this angle corresponds to this angle, or you can say on the other side, this angle corresponds to this angle. And there's my two angles just by AA similarity theorem. But you've also got this reflexive angle up here, angle F congruent to itself. So it's your choice. You just need two of them. You can do two correspondings. You can do one reflexive and one corresponding. It's up to you. I'm going to say angle F is congruent to angle F by reflexive. I'm going to say angle FTS is congruent to angle FOC by parallel lines mean that corresponding angles are equal. And then I can say that triangle FTS is similar to triangle FOC by AA similarity theorem. Here we go to solve. Over here I've got the x. That x is part of the big side, x plus 9. So when I'm trying to solve for x, I need to put it in terms of the big because I want to go big as to small. So I'm going to say big is as small as x plus 9 is to 9 and then on the other side, big is to small. We multiply, we get 99. So I'm getting x is 36/7, which is 5.14. How's that look? All right, next one. Oh, we've got right angles. So there's our two angles. We've got angle S congruent to angle S. We've got angle TNS, angle EVS. And now we can say triangle TNS is similar to triangle EVS by AA similarity theorem. Here I go to solve. Big is to small as big is to small. 100 divided by 8 on your calculator. 12.5. I guess I don't need the approximation bar. All right, we did this number 4 in class. Again, you can use both the correspondings or one reflexive and one corresponding. Okay, once I prove similarity, then I can go solve for x by saying this whole big is x plus 2. This whole big is x plus 7. So we got to go small is to big or big is to small. It's up to you. So big is to small as big is to small. Go ahead and cross multiply that. So I'm getting like 14 thirds. So grab a calculator. 4.67 is what you guys told me in class today was the rounding. Okay. So this next one does have the reflexive angle just like this one did. But then look, it's another side ratio problem. So we need to give side ratios. So for example, I'd say like SE is to PE as LE is to RE. Now, for some reason, I keep accidentally doing small is to big. You know, you can do big is to small instead too and get like better whole numbers instead of these weird fractions I keep getting. But so here we go. Small is 28, but then the big is 28 plus 42, which is like 70. And then small is to big. So what goes into 28 and 70? How about 7? What goes into 20 and 50? 10. Oh, I guess 14 could have gone in. This one actually reduces down further to 2/5. So, hey, look at that. Ratios of corresponding sides are equal. So my triangles are similar. Triangle SLE is similar to triangle PRE by side angle side similarity theorem. Here I go to solve. Big is to small as, and you can use either top or bottom. I'm going to go big is to small. So we get 20x. What's 14 times 50? Is that like 900? Can you do that in your head? 700. I was way off. Divided by 20. We get 35. No rounding. Okay, we've got vertical angles and alternate interior angles. So we can say angle ma is congruent to angle car by vertical angle theorem. And then we can say angle M is congruent to angle K by alternate. Parallel lines mean alternate interior angles are equal. And then triangle ma is similar to triangle car by a similarity theorem. Now we go left is to right as left is to right. 7.8x equals 3 times 2.9, 8.7. 1.12 inches. Speaking of inches, make sure we put units on everything. This one is miles. This one is nothing. U for units. This one is centimeters. This one is feet. And this one is nothing. U for units. Yay, we're done.